Okay, it's my pleasure now to welcome back Mayuka Vadari. Mayuka is a software engineer at Ripple, and she'll discuss the new xrpl.js library, which is a rebuild of the former Ripple lib.
Those of you who tuned into my presentation yesterday about xrpl.py might feel a little bit of deja vu, because as it turns out, it's really hard to write two wholly different presentations for two very similar topics. Now, with that said, let's start with a show of hands and comments in the chat. How many of you have heard of Ripple lib or xrpl.js prior to Apex? Seeing quite a few hands here. And how many of you have built on top of Ripple lib? Okay. So Ripple lib is the main supported TypeScript and JavaScript library for the XRP ledger. It's been around for as long as the XRP ledger has, basically. So, basically forever. And if you look at some parts of the code base, you can kind of tell. So a few months ago, my colleagues and I embarked on an adventure to revamp Ripple lib for version 2.0 for the modern age. And in the process, we renamed it to xrpl.js to better represent its purpose. There is a beta out now, and we'd appreciate all of your feedback. The library now closely mirrors RippleD in its interfaces, which makes it easier to use multiple sources of documentation. For those who aren't familiar, RippleD is basically the implementation of the XRP ledger protocol itself. There are TypeScript types for all the RippleD request methods and transaction types. And for JavaScript users, there are a few handy methods that you can use to check the shapes of your transactions to make sure that they are indeed valid before submitting them to the ledger. The network client that comes packaged with this library is a robust WebSocket network client. And there's also an experimental broadcast client that allows you to connect to many different nodes. There's a wallet class that you can use to store and interact with your key pairs. And there are native signing and serialization functionalities to make it incredibly easy to work with your transactions and do all of that signing and submitting. There are a number of convenient helper functions as well, such as getting the current transaction fee, getting the balances for an account for all currencies, and getting the entire order book between two currencies. As for differences from Ripple lib version 1.10, there is much less abstraction from RippleD now, and the interfaces mirror each other a lot more. This makes it easier for developers to use multiple sources of documentation. They can use the RippleD documentation, they can use library-specific documentation, and they can use whatever other XRP ledger documentation is out there. This means that it's really easy for developers who are new to the XRP ledger landscape to be able to access many different sources, many different resources. And the idea is that for those who know the XRP ledger well, it's a lot more of a familiar interface for them. There are much better request and transaction models, and all RippleD request methods and transaction types are supported. There are also a number of general architectural improvements, such as simplifying code, revamping the testing framework, and simplifying the user interface to make it more intuitive. So now let's see some sample code. I'm going to show you how to connect to the ledger, how to send requests to get information from the ledger, how to create and send transactions, and how to check if your transactions were actually successful. Going to zoom in a little bit for you guys. So first thing we got to do is create a client so that we can actually connect to the ledger. So just going to import that from our library. And we can create a client. And we can connect this client to the testnet. And so now let's connect to now we can actually connect the client to the testnet node, and then we'll make sure that it actually is connected. And this will take a sec, but now you can see that it is in fact connected. So now we need a wallet in order to do basically anything on the ledger. So we can create a wallet by using a generate faucet wallet method, which connects to the testnet faucet and generates a wallet for you that has some seed XRP. Now we're just confirming that the transaction has indeed gone through. And so now we can print out this wallet. And you can see the public key, the private key, the classic address, which is the standard address form, and the seed that we can use to generate this wallet again. So now that we have a wallet, we can create, we can check the balance of this wallet to make sure that it actually has XRP. And we can just pass in the wallet's classic address here. And so now you can see that in the XRP currency, it has 1,000 XRP. So now let's send a payment. We can, since this is TypeScript, I can import the payment type from the xrpl library, and this isn't. And now you can see that the TypeScript is in fact yelling at me because I haven't actually put anything in this object that I'm supposed to put. So we can create transaction type. We want it to be a payment. And then the amount, we can do something like 30 XRP, which we got to convert to drops. So we can pass in 30 to that. And then destination is this address that I've got stored in my clipboard, and then the account that we're sending from is the wallet's classic address. And now I gotta actually import that XRP to drops function. And now you can see that this object, that this has been created. And so now we need to fill in all the other parts of a transaction that are necessary to send it to the ledger, such as the fee, the sequence number, and the last ledger sequence number. And so there's a nice function called autofill that will do this for you. And you can just pass in the payment here. And then you can print it out here. And now you can see it's got a flags field, a sequence field, a fee, and a last ledger sequence. The sequence number makes sure that you can't send a transaction twice on accident. The fee is just a transaction fee in drops. And the last ledger sequence number basically means that you can't, if that ledger sequence goes by, then the transaction won't pass anymore. This is just to make sure that you don't submit a transaction, it doesn't work for some reason, but then like a month later, it somehow works because of some change in the ledger. And then we can sign it. And I gotta import the sign function now. I forgot to pass in the wallet. And I switched the order of the arguments. Live demos. There we go. There's our signed payment, which has been serialized for us. And then we can pass that in to a nice function that'll automatically do this, that'll automatically send a signed transaction for us, which is conveniently called submit signed transaction. And now if we print out this response, we can see that it was indeed successful. And then now I gotta, oh no, it was not successful, I'm blind. So turns out that I was talking too long. So the last ledger sequence number that we put over here already went by. So let's just rerun this in quick succession so it doesn't have time. And now when I print this out again, you can see that it was successful. And now I have to stall for a few seconds because xrpl.js right now does not have a reliable submission function that waits until the transaction has been validated. So got to wait for the ledger to validate the function. And now when I reprint out the XRP balance, you can see that it's gone down by 30 XRP and 12 drops from the fee. And got one more trick up my sleeve. So instead of needing to do these 3 functions, the autofill, sign, and submit, you can actually do it all in one convenient function called submit transaction. And you can just pass in the payment and the wallet here, and which I again switch the parameters there. And then you can print that out, and you can see that it's successful again. And we can wait a few seconds again for the ledger to hopefully validate this function. And now you can see it's dropped by another 30 XRP and 12 drops. So the same thing happens there. And we can actually check on the ledger that this transaction has gone through. We can take this transaction blob here. We can take the hash that we have returned here. We can copy that, and we can run a TX request on the ledger and see that it's still there. So we can just pass in this request here, command TX, and well, actually, let's create this request first. TX request. And so we can create this request here and get TypeScript to help us out a little bit. So the command is TX here, and the transaction is this hash that I just copied, and then now we can submit it to the ledger to get the information about the transaction back. And so now we can see that this transaction appears, so we know that it has indeed actually been submitted to the ledger and that everything works perfectly. And there's a lot more to look forward to as well. We are looking to release the official version of xrpl.js 2.0 soon, after we have incorporated all of your feedback into the new version. We're also looking to add a reliable submission method, which would have been helpful during my demo here today, to make sure that you know when the transaction has been fully validated on the ledger. And we're also planning on adding NFT support to the library as well, which you saw my colleague Greg demo earlier today. So please check out the new version of the library on GitHub or on NPM. We'd love to get all of your feedback, and you can give us your feedback by either dropping an issue in GitHub Issues or talking to us here at Apex, either in person or via the app. And if you have a project that's in RippleLib version 1, we'd love to talk to you about the migration process. Thank you.